If you've ever grown a houseplant, you probably followed the same basic recipe. Grab a pot, fill it with dirt, plant your seed, and add water. But dirt actually makes the plant work quite hard. To find water and nutrients, a plant has to expend its energy pushing roots through heavy, dense soil. Hydroponics is a way to skip that struggle. Instead of making the plant hunt for its food, we remove the dirt completely and deliver water and nutrients directly to the bare roots. There's a specific way to do this called the nutrient film technique, or NFT. And don't worry, this has absolutely nothing to do with cryptocurrency or buying digital art. In this case, the word film just means a very thin, shallow stream of water. Think of it like a miniature lazy river that constantly flows right over the plant's roots. Stripping away the soil and replacing it with this shallow stream allows a plant to grow significantly faster while using a fraction of the resources required by traditional farming. If you walk into a modern indoor farm, you won't see fields of mud. Instead, you'll see rows of clean, white channels stacked from the floor to the ceiling. Let's look at how one of these channels actually works. The main vessel is usually just a long PVC pipe. It has holes drilled evenly along the top, and it's tilted down just a tiny bit at one end. A baby plant is held in a small cup with slots in it, and then dropped into one of those holes. Because there is no dirt, the roots just dangle freely into the empty, dark space inside the pipe. Down below the pipe sits a reservoir tank holding a mixture of fresh water and dissolved nutrients. A mechanical pump pushes this nutrient water up a tube, releasing it into the elevated end of our slanted pipe. From there, gravity takes over. The water flows down the incline, forming a shallow stream that brushes right past the tips of the dangling roots, before dropping right back into the tank. This creates a closed loop. The water cycles continuously, creating a zero-waste delivery system that keeps the plants perfectly hydrated. You might be wondering, if we actually want to hydrate the plant, why use such a paper-thin stream of water? Why not just fill the entire pipe up to the brim? It comes down to basic biology. Plant roots need to drink water, but they also need to breathe oxygen. If you fully submerge them in a flooded pipe, they will literally drown and die. That thin film hits the biological sweet spot. The very bottom tips of the roots drink from the flowing stream, while the entire upper section of the root mass is left exposed to breathe the open air inside the pipe. But this perfect balance comes with a major catch. In a traditional garden, dirt acts like a big sponge, holding on to moisture for days. Here, there is no sponge. If the power goes out or that mechanical pump fails, the water stops flowing immediately. Without soil to protect them, the roots will dry out and the entire crop can perish in a matter of hours. An NFT system operates much like a high-performance race car. It is capable of producing high yields in a very short time, but it relies entirely on constant, uninterrupted mechanical maintenance to stay on the track. Growers take on that mechanical vulnerability because of the results they see above the waterline. Without the resistance of dense dirt, the plant can focus more of its energy on expanding its leaves and stems, resulting in a much faster path to harvest. The physical result is rapid, vibrant growth. Leafy greens, lettuce, and herbs grow massive and crisp, reaching the size we want for our dinner plates much sooner than they would in a traditional farm. This chart compares water needed for traditional farming versus hydroponics. Because our lazy river continuously recycles, it uses 90% less water to grow the exact same amount of food. And because we are using lightweight modular pipes instead of flat plots of land, we don't need sprawling acreage. These modular channels can be stacked vertically, turning small apartments or urban warehouses into highly productive indoor farms. Harvesting a crisp salad in the middle of a high-density city is now possible with a little biological balance, a simple water pump, and a gentle indoor lazy river.